Okay, student, see your next topic, indefinite integral, which is a very important topic for you, and this topic is related with your differentiation because most of the differentiation formula here used. See the first definition related to primitive or antiderivative. A function phi x is called a primitive or an antiderivative or an integral of a function fx if phi dash x is equal to fx. For example, x to the power 4 upon x is primitive of x cube because when we differentiate x to the power 4 upon x, the value will come x to the power 3. Let phi x be primitive of a function fx and c be any constant, then you also differentiate d upon dx phi x plus c. The value will come phi dash x, which is equal to fx. So phi x plus c is also a primitive of fx. If a function fx represents a primitive, then it represents infinite many primitive. You can see here. See the example, d upon dx x to the power 4 by 4. The value will come x to the power 3. Again you differentiate d upon dx x to the power 4 by 4 plus 1. The value will come x to the power 3. Again you differentiate d upon dx x to the power 4 by 4 plus 5. The value will also come x cube and so on. So the family of all its primitive or antiderivative is also known as indefinite integral of fx, and it is represented by the symbol integration of fx dx. Thus, d upon dx phi x plus c is equal to fx if and only if integration of fx is equal to phi x plus c. On the behalf of this, you can see next topic, fundamental integration formula. Since d upon dx phi x plus c is equal to fx if and only if integration fx dx is equal to phi x plus c, on the basis of above definition we obtain the following integration formula. First, d upon dx x to the power n plus 1 upon n plus 1 is equal to x to the power n. Then implies that integration of x to the power n dx is equal to x to the power n plus 1 upon n plus 1 plus c, where n is not equal to minus 1. Again d upon dx log of x is equal to 1 upon x, where x is not equal to 0. Implies that integration of 1 upon x dx is equal to log x plus c. Next, d upon dx e to the power x is equal to e to the power x, implies that integration e to the power x dx is equal to e to the power x plus c. Next, d upon dx e to the power x upon log x log a base c is equal to e to the power x, where a is greater than 0. So implies the integration of e to the power x dx is equal to e to the power x upon log a base c plus c. Again d upon dx minus cos x is equal to sin x. Then implies that integration of sin x is equal to minus cos x plus c. Next, d upon dx of sin x is equal to cos x, then implies that integration of cos x dx is equal to sin x plus c. Next, d upon dx tan x is equal to sec square x, then integration of sec square x is equal to tan x plus c. Next, d upon dx minus cot x is equal to cosec square x, then implies that integration of cosec square x dx is equal to minus cot x plus c. And next, d upon dx sec x is equal to sec x tan x, then implies integration of sec x tan x dx is equal to sec x plus c. Next, d upon dx minus cosec x is equal to cot x cosec x, and implied integration of cot x cosec x dx is equal to minus cosec x plus c. See the next formula, d upon dx log sin x is equal to cot x, then implies that integration of cot x dx is equal to log sin x plus c. Next, d upon dx minus log cos x is equal to tan x implies that integration of tan x is equal to minus log cos x cot x. Next, d upon dx log sec x plus tan x is equal to sec x implies integral of sec x dx is equal to log sec x plus tan x plus c. d upon dx log cosec x minus cot x is equal to cosec x implies that integration cosec x dx is equal to log cosec x minus cot x plus c. d upon dx sin inverse x upon a equal to 1 upon root of a square minus x square, then implies d integration 1 upon root a square minus x square dx is equal to sin inverse x upon a plus c. Next, d upon dx cos inverse x upon a equal to minus 1 upon root of a square minus x square implies integration minus 1 upon root of a square minus x square dx is equal to cos inverse x upon a plus c. Next, d upon dx 1 upon a tan inverse x upon a equal to 1 upon a square plus x square implies integration 1 upon a square plus x square dx is equal to 1 upon a tan inverse x by a plus c. Next, d upon dx 1 upon a cot inverse x by a is equal to minus 1 upon a square plus x square implies inverse integration minus 1 upon a square plus x square dx is equal to 1 upon a cot inverse x by a plus c. d upon dx 1 upon a sec inverse x by a is equal to 1 upon x root ax square minus a square implies integration 1 upon x root x square minus a square dx is equal to 1 upon a sec inverse x upon a plus c. Next, d upon dx 1 by a cos sec inverse x by a is equal to minus 1 upon x root x square minus a square implies integration minus 1 upon x root x square minus a square is equal to 1 upon a cosec inverse x by a plus c. Next, some result on integration. First, d upon dx integration of fx dx is equal to fx. Next, second, integration of k times of fx dx is equal to k times of integration of fx dx where k is constant. Next, integration of fx plus minus gx dx is equal to integration of fx dx plus minus integration of gx dx. On the behalf of above formula, you can solve the exercise 7.1 and 7.2. Next, some again new topics which is very important for you, that is method of integration. In this, the method of integration, we have the following method of integration. First, integration by substitution, integration by parts and integration by partial fraction.